Okay, so your doubt, I'll clear that. But before that, some basic you need to know. And the basic is that what electrostatics is all about. Electrostatics basically is nothing else but it's a surface phenomena. You need to understand this very well. That what is surface phenomena? That means my charges will be settled at the surface. So if this is, let's say, my spherical body, then the charges will be settled at the surface. So if this is my sphere, a metallic sphere, charges will be not inside, it will be at the surface. If I am talking with regard to line charges, I have some line charges like this, then in this case also, what happens is that the charges are in line. But if I am talking with regard to inline, it means, let's take an example of a rod, a simple metallic rod. On the surface, what you will see? The charges. So rod. At the surface, sphere. Let's say I am talking with regard to cylinder. If I am talking with regard to cylinder, again the charges will be at the surface. Nothing inside this. So far one thing is clear, that if I want to find the charge density, let's say I want to find the charge density over here. First understand what is the meaning of charge density. It means that what amount of charge at a given surface is occupied. Basically for a rod, the charge density what we use is linear charge density. Linear charge density. Why? And the reason for linear charge density is because on the rod the charges will be on the surface. We don't take it as a cylinder because the length of these charge charges are so large as compared to the diameter. So therefore we consider only one thing over here, is that it's a line straight charges, linear charge. Linear charge density is, in many textbooks it may be different, but it's the lambda which we use for linear charge density. So how do we define now linear charge density? It means it's charge per unit length. So whatever the total number of charges per unit length. So basically it will be coulomb per meter. Coulomb per meter will be the charge, linear charge density. Now if I am looking at a sphere or a cylinder, again the charges will be at the surface. So we don't have to discuss with regard to volume here at all, because the charges are not concentrated inside. Charges are settled at the surface because it's a surface phenomenon. So if I am talking with regard to surface, you need to know very well the surface area of some regular objects such as sphere. If I am talking with regard to sphere, the surface area of a sphere is 4 pi r square. If I am talking with regard to surface area of this, which is called as curved surface area, which will be actually 2 pi r h. If I am taking h this much, then this is h. You can take it L also. So curved surface area and surface area. Now if I want to find the charge density over here, what we do? I use sigma. Charge per unit area, not volume. Why not volume? Surface phenomena. So what I will get here is the charge upon area, which is 4 pi r square. I want to do it for cylinder. Charge upon area, curved surface area, 2 pi r h. You can take any regular object, but you need to know their curved surface areas very much. Now in cylinder what happens is that, why I am talking with regard to curved surface area, we don't take this surface, that is the plane surfaces, is because the axis is like this, and for this axis, if my theta, that is the electric flux, if I am talking about phi e, it says EA cos theta. Theta is the angle between electric field and the area. So if my electric field is in the outward direction, something like this, then if this my electric field is like this, okay, and if I am looking at the area, it's like this in the same direction, so theta over here is 0. But if I am looking at the plane surfaces over here, plane surface, this is my area, So area vector for this will be something like this. Area vector perpendicular to the surface. So the angle between area vector and the surface is theta, which is 90 degrees. Cos 90 will be 0. So electric flux through this surface will be 0. Same way electric flux through this surface is also 0. So we don't consider that. Overall what we consider is the curved surface. Are you getting it? Now, what is difference between all of them? If I am talking with regard to linear charge density, why I am dividing by the length, that's per meter. But obvious because it's one dimensional. Spherical body will be considered as three-dimensional area. Cylinder, if you are talking about, I need only the height over here, can be considered as 3D, can be considered as 2D. But since we are talking only with regard to curved surface area, like this example, we take this as 2D and therefore we get surface area like this. If you are talking with regard to quadrants, my quadrants are actually 2D. So if you are talking with regard to quadrant and if you want to find the surface charge density over there, what you have to do is that you have to first precisely see will it qualify under a 2D or a 1D. Also, if it's a Gaussian surface I can draw, then I can draw any such Gaussian surface which will be symmetrical. That means it should be symmetric and my charges should be distributed equally on both the sides. Take an example over here what symmetrical Gaussian surface means. My sphere is a symmetrical Gaussian surface. My cylinder is a symmetrical Gaussian surface. It's because if I divide it into two halves like this, the number of charges on this side and this side will be distributed equally. Same thing here also. If I divided this sphere, number of charges distributed equally. Gaussian surface, a very important part is that I can select any surface geometrical object, but it should be symmetrical. So now the big question is that, can I select any other such geometrical objects which can be symmetrical? Think and let me know. Thank you.